Hello everyone! In this video I will talk about the technical part of the project. Maybe the contents of this video will be useful for your own projects. There are three pillars this project is built on: combination of textures and the shader, as well as post-processing. Some of these methods are well covered online and some are not. Let's start with the textures and the shader. As the foundation, I used a well-known Substance Painter plugin called Pixelator, which converts any PBR textures into an arcade pixel visual style. It enables users to apply dithering, palette quantization, custom color palettes, and pixel resampling to textures. There are no secrets here. It is a very popular solution. Yes, it costs $35, but it is worth it. I took this plugin, experimented with it, and adjusted it for my task to achieve the desired look. I used 3 channels for a more contrasted result combined with more flexible settings. Each channel projects light from a desired position and gives it the final look I want. For the expert settings you can use the standard preset, but the only maps we need are the normal map and the base color. Later we will combine the following textures together. Next, to add depth to the texture, I use Photoshop, combining 2 textures into one according to this principle. Of course there are other ways to do this, for example in Designer using the height to normal node, plus levels, plus multiply blend, but that is mostly a matter of taste and convenience. But the material shader is the most important part here. Let's talk about it first. To achieve the desired look, first of all, I go to my texture base color texture and then take the sRGB color texture option. Then I plug it into my custom shader and freely control its brightness and color hue if needed manually. This material is based on the standard Unity Lit, and technically the same look could be achieved with it, but that version uses too many unnecessary inputs and can slow down your workflow and increase hardware load. That's why for my work I made a material with only one output. I use this shader for all objects in the scene except the windows. For the windows I use the standard lit shader with the following parameters. If anyone is interested in getting this custom unlit shader, I will share it in the description. Next is lighting and post-processing. To finalize the appearance I used an effects pack from the Unity technologies, specifically 4 effects: fog, fire, water, and dust. I will attach the link in the description. Ambient occlusion has slightly modified settings. In this case, it is needed so that the objects look cohesive. You can add up more fun to it if you play around with depth settings and take downsample, which gives ambient occlusion that grungy look and can make it more stylized. This option works well in some cases, but in others not really. Depends what look you are going for. But the most important part is the post-processor using a gradient filter. To simplify the workflow and reduce hardware load, I attach the gradient to the camera instead of the 3D space, which also looks slightly more surreal and stylish. Here, I can control the jitter spread and especially color resolution. The higher the color resolution, the more colors it renders on the screen. That way giving me more flexibility to stylize the look of the scene. As you see, the gradient filter does make a lot of difference, giving the image that finalized and polished look by adding more depth and quality to the image. So how does this gradient work? The UV node sends screen position data into 2 paths. One path samples the scene color, The other path samples a dither texture. The dither texture output is adjusted with subtract and multiply to create a threshold pattern. That pattern is added to the scene color so every pixel is shifted up or down depending on its position. The result is multiplied by the color resolution value, then floored, which forces the color into fixed steps. Dividing brings it back into normal range, and the final output is the scene color with quantized color steps and a dither pattern applied. The result of combining all these methods is the image you see on the screen. Hopefully this video will be useful to some of you. Thank you for watching.